Good evening, everyone. Thank you, first of all, to VJ for having me back. I was with a group of developers who worked on a React open source project having to do with server-side rendering, and we had a lot of fun speaking together. It was 5 of us passing off the speaking roles back and forth for the course of the meetup. So this time I'm holding down the fort alone, but I'm excited. I'm very excited to have a chance to nerd out with you guys for a little bit about JavaScript modules. And this is a topic that I think is particularly fascinating because when we look at the history and the development of modules in JavaScript, we're kind of going in parallel with, we're tracing the history of JavaScript growing as a language from kind of humble origins as this lightweight scripting language that was running in Netscape to really becoming a powerhouse that gives us the modern web with all of its interactivity and everything that we love about it. So now we're basically in an era where we have JavaScript running everywhere, universal JavaScript, JavaScript on the client and on the server side, we have it in our thermostats, even flying drones for us. So needless to say, JavaScript has come a very long way, and so have modules. Oh, and the pronunciation of my name for anyone who might have been wondering is Mejin rhymes with region. So just, well, anyway. So the first thing that I would like to posit is that modules are a fundamental part of our lives as JavaScript developers. They're kind of part of the scenery. So I do a lot of my day-to-day work in a React code base. So when I fire up my code editor, many of the files I'm looking at have kind of a predictable structure. I see some import statements at the top, some export statements at the bottom. I almost don't even think about them. I mean, unless I've put a typo in my file path or something, then I am thinking about them. But I imagine there are other folks in the room working in other frameworks and working in other modular type code bases and environments. So modules and modular thinking are kind of second nature to us, and that's really how it should be. Modules are supposed to make our lives easier as developers. They do this by giving our code structure and boundaries. So that way we don't have to think about all of the moving parts. I don't have to have the React source code mingling with my component logic. I can take for granted that it's going to be available for me and do what I want it to do most of the time. So for now, it resides elsewhere, out of sight and out of mind. And this is especially important as code bases get bigger. So when we hear about terms like modularity and separating concerns, that's really about our sanity as developers who are working with each other and working with a lot of code. So let's start out and get on the same page as far as our concepts and terminology. We'll start with the basics. What's a module anyway? I like to think about modules as building blocks of data and functionality. And we can bring them into a program, and we can also make them available to other programs. And ideally, you can kind of treat them like you would building blocks, and hopefully you can add or remove pieces from the whole without the whole structural integrity falling apart. So when we're talking about modules, we're really talking about the higher level design of our software. We're often thinking about modules in terms of a single file, because that's typically how we organize our modules, one module, one file. We can also talk about modules in terms of their relationships to other modules. So a module has an interface, and that's its exposed bits that let us have data and a functionality available for use in other programs. I kind of like to think of the module interface as the little bumps on the top of a Lego brick. So you can try to put your Lego bricks side by side, and they won't really stick together, but those little bumps, which I actually just found out are called studs, Lego studs, are how we actually get our structures to stick together. And so module interfaces are a little bit like that. And a module can also have dependencies, and often that just means that we're dealing with other functionality that we're relying on to have the functionality of whatever module we're working in. And so just to hammer it home, in case there's any ambiguity about my personal position on this, modules are awesome. They help us to keep organized code bases, especially as those code bases are growing in complexity. They help us resolve our dependencies, making sure that any pieces of code are supposed to be there and we don't have to worry about getting them all in the right order. They also help us to share and reuse code. So we have a wonderful thing called NPM that gives us access to literally, I think, 700,000 packages right now. A lot of packages of code. And we ourselves can be part of a community contributing to that global repository alongside others. So kind of cool. But before we go any further, there is an elephant in the room, and we should acknowledge it. So these modules, which I've been talking about and that are so fundamental to modular and modern programming, are actually just barely a part of JavaScript. They weren't built into JavaScript pre-ES6. So for most of its years as a language, JavaScript didn't have any kind of built-in native module system. So this is unlike Python, for example. And so modules only really recently became part of the language, and they've actually only just landed in modern browsers, like as of this year. So oftentimes when we're working with modules, we're not working with the built-in module system at all. We might be using require statements if we're working in Node or Commonjs. We might be using import statements like I showed earlier from React code. We might be using Babel to transpile them down to ES5 and then to bundle those files that were all supposed to be separate into a single one for consumption by the browser. So what's going on? Well, this is where I started getting curious. Like, how did we work for so long without modules in JavaScript? And as I started to take a peek into the history, I found that there was this overarching storyline that JavaScript was really built disadvantaged when it came to modules. It wasn't built with any kind of modularity in mind. When it was first invented, it was just supposed to be lightweight scripting, inline scripting. And over time, as more demands were made of JavaScript as a language to do more for us, we see an increasing need, so running in parallel, for usable module systems. So I like to think of the history of JavaScript as unfolding in 4 phases. I made these up, so I call it the PreModule Era, the DoItYourself module phase, the specification phase, and the standardization phase. And because it is something I made up and because it is a system of chronology, it is not perfect, not precise. But what I was aiming to do in kind of splitting our timeline into these 4 segments was to bring some order to overall trends that were taking place. So I'll do a little flyover right now before we jump in and get into more detail for each of those phases. But let's start at the beginning in the pre-module era, when modules were not really a thing at all. JavaScript didn't itself have much of an identity or much respect, let's be honest, at that point. It was nothing like it is today. That didn't last too long before we started realizing that we needed some kind of modules. But in the absence of those built-in modules, we were improvising. We were making module type structures ourselves. So roughly in 2011, we start to see module specifications growing in popularity. The JavaScript community, especially the server-side JavaScript community, was really starting to take off. And a lot of work had to be done just to make JavaScript the language people wanted to develop in. And a big part of that was just coming onto the same page. So that's also kind of our era of single-page apps and frameworks like Backbone and Angular starting to come into vogue. And finally, today, we have arrived in the era of standardization, and that's the phase that is currently underway. And I hate to spoil the plot right at the beginning, but JavaScript is still pretty far from having a standardized module system. We do have a standard system in place, but we're still working out the kinks, and we're still making things hold together in the ways that we hope that they will, so that one day we will all be gloriously developing with modules and not having to think about all the quirks that go with trying to do that. All right, so let's begin our tour. We begin in a time before modules, JavaScript's age of innocence. And as we peek into the yearbook, dun dun dun, we come across gems like this. So totally 90s. And I'm calling this the dark ages, but really, I think we were probably having a good time. Anyone had a GeoCities website? I sure did. I think it was called like the Raspberry Garden or something. It was like 12. Anyway, it had all these cool neighborhoods like Soho and Sunset Strip and Times Square. And I guess you can go to the Wayback Machine if you want to have some nostalgia. But anyway, as I'm looking at this specimen from the archives, I think I'm seeing at least for sure one definite use of inline scripting, which is probably like this fun little animated status bar that's crossing the screen for your entertainment. Anyone spot any others? That's the only one that I feel like kind of confident on. What a time. What a time. But anyway, yes, a wild west of inline scripting and script tags. No modules to speak of, really. A question I want us to start thinking about is this scalable? What are some of the problems we encounter in this Wild West scenario? Well, I'll say more about that in a moment, but first, let's get one thing straight. At this stage in the game, no one was really thinking about scalability. That was not the name of the game. And if you don't take it from me, take it from the inventor of JavaScript himself, Mr. Brendan Eich. I hope he pronounces it that way too. I could be butchering it, but he did say in an interview with InfoWorld that no one thought JavaScript would be used at the wide scale that it is. Not just reaching lots of people on the web, but large applications like Gmail. To write large code, you don't just want this little snippet language that I made for beginners. You want strong APIs and ways of saying, hey, this is my module, and this is your module, and you can throw your code over to me, and I can use it safely. So quick trivia question. Does anyone know what year JavaScript was invented? Any guess? 95? Or did you say 95? That is exactly right. Over the course of 10 very intense days for Mr. Eich. And I think his original instructions from Netscape were actually to have a language that was a lot more like Scheme for the browser. So if anyone's worked with Scheme, which is kind of a dialect of Lisp, you know it looks completely different from the JavaScript we know and love. Those instructions, those marching orders changed significantly, and I feel grateful for that. So in 2006, we get the first of several manifestos that we will see. So this particular manifesto came from the Yahoo user interface team in a blog post with the title Global Domination. And they had a good point, I would say. And the point that they were trying to make is that global variables are a terrible, risky practice that we're all engaging in, this unsafe behavior that we're all engaging in. But in growing code bases, we really had to cut that out. And so what's the problem? Well, global variables are notoriously unreliable and insecure, and there are a few reasons for that. And the first has to do with variable naming collisions. So assuming Mary and George on the UE dev team are working on the same code and named their variable the same thing, they were likely to run into trouble. Pollution in the global namespace. And globally scoped variables are just, well, they're just really easy to break or to forget that they even exist. And secondly, because they're exposed, they're not secure. So it's not just coworkers who might innocently bump into each other in the global namespace dance floor. Third-party scripts and malicious code might join in the fun. And global variables are a vulnerability that we generally want to avoid, especially if we're Yahoo and we're the big guns in the game in the mid-2000s. So the UE team actually went as far as to say that an objective measure of the quality of a JavaScript program is how many global variables and global functions does it have. A large number is bad because the chance of bad interactions with other programs goes up. And a few other issues were cropping up in this era, in this pre-module era. Whenever you wanted to reuse code, you'd likely be doing some kind of copy-paste job and then following the trail of breadcrumbs wherever it led you. And anytime you tried to update your code, it would likely be a logistical nightmare as you tried to find all the places where you needed to update it. Dependencies were a hassle to manage, especially if you were dealing with version control. You had to worry about putting your script tags all in the right order. And basically, as code bases were getting more complex, we needed a way to manage them better. So let us set foot into the next era, do-it-yourself modules. And in this second phase of JavaScript history, not all of the problems from the pre-module era were going to go away right off the bat, but we'll start to see some of them being addressed, particularly the problem of global variables, because that was an immediate concern. So this insight about needing to limit global variables actually spurred a ton of innovation and improvisation, really, with what was possible within the constraints and flexibilities of the JavaScript language. And this was really an era of transformation for the web. We're really moving away from the GeoCities model of static websites. We're moving toward more interactivity. And AJAX requests were becoming more of a norm during this period. jQuery hit the scene during this time, and the web was really starting to grow up a little bit from websites to web apps. And so let's just keep that in mind as we start to look at some of the ways that people addressed the shortcomings of living in a world without modules. We'll pick up the story where we left off with our friends at Yahoo who had just declared that global variables are evil. And their answer to this problem of global variables was actually just to restrict them. Let's stick with a single object with godlike status, the Yahoo object. And the aim of the Yahoo global object was literally to contain all of Yahoo, their state, and all of their web state. And being in all caps, you can tell that it was very important. It was the global. So if you wanted to do anything, you would say yahoo.util.dom.get, or whatever it might have been. You were somehow crawling through this object tree to find what you wanted. And jQuery might be a more familiar example. You might remember having to have the jQuery object available in global. But as much as this approach was touted as great practice, there were definitely downsides to it too. So it was still relying on a global variable, a single one that could have been rewritten with a single line of code, and then poof, potentially, everything could be gone. There was still no code reusability and really no help with dependency management or versioning. But you were starting to mitigate some of the risks of just having free-range global variables. So the basic structure of the namespace approach looks kind of like this. We've got an object literal here, and we've got some properties on it, some data, and some functionality. And we can assign those additional properties, additional data, while we're declaring that namespace object or after the fact. with our handy dandy dot notation. And let's look at another approach that started coming up in this era, and that's the module pattern. And the essence of the module pattern is being able to use an immediately invoked function expression with the power of closure. So the power of closure is that it would shield private variables from being accessed outside of that function scope. And as most of you know, closure is what allows us to have access to the variable environment of a function even after we've exited its scope. So you'll continue to see this pattern as we move along, that function scoping is how we're going to start to get these boundaries and start to collect our variables in places where we can kind of protect them and not have them hanging loose everywhere. Control yourself, JavaScript. So here's a rather simple example of the module pattern in practice. So this my DoItYourself module, we're assigning to it the return value of this iffy. And in that iffy, we've got in our closure scope some private variables, and then we've got our exposed functions that are returned via an object with the increment and print properties. And so, as one might expect, you can call the print function and find out what your counter variable's value is at any point. You can call the increment function, increment your counter. If you printed it again, its value is 1, but you cannot access that counter directly. That is the important thing. Thanks to our function scoping, it has lived, it is gone, you can't touch it. And here's another popular implementation from back in the day, also the module pattern, just a flavor of it, called the revealing module pattern, which is almost exactly the same. But in this case, both our public and private variables are declared outside of the return statement. So pretty much everything, all of our variables are being defined in closure scope. And we're selectively revealing what we want to. And my understanding is that this revealing module pattern was mostly just readable. It was easy to use. It was easy to work with. You could work mainly within that returned object and decide what you wanted to have and what you didn't want to have included. You didn't have to use the this keyword as much when you, well, at all really. You could simply refer to variables by name. Potential disadvantages of this approach. This was actually considered by people who were thinking about it, one of the most fragile ways of actually implementing the module pattern. You might imagine that if you had some public variable that you were trying to change, say you were trying to reassign it after having declared it, and suppose you also had a private variable in here which somehow used or depended on that public variable. Well, you might have a little bit of trouble and not get what you expect because these variables are defined in this function scope. What's accessible to those private variables and to private methods is the closure functionality, is what was in this function scope at the time this iffy was invoked. And so you might, basically this is just to say that you might get some unexpected results. It wasn't the best of the module pattern, but it was out there quite a bit in the wild. And just so we're clear, namespaces and the module pattern are not mutually exclusive approaches. They often did go hand in hand, which is something the late Doug Crockford advised. So here we've got a variation of the module pattern that takes a namespace object as a parameter. You can also sometimes find this out there with the .call function, and you're using the .call function and passing in the namespace object, and then you just use the this keyword instead of having that namespace in there as a function parameter. But anyway, same kind of idea. We pass in the namespace. add some data and functionality to the namespace, but we've got privacy. We've got that privacy that that immediately invoked function scope provides us, thanks to closure. So JavaScript is kind of cool. OK, so that's a wrap on our quick, blazing tour through the early module era. And as you can see, the tools within JavaScript did take us a long way towards solving the global namespace pollution problem, but we still feel like we still weren't where we wanted to be. Ifys still felt a little like a hack job. We were still dealing with this giant global God object. And we still had some problems that remained. We never got to the point that we were able to actually swap modules with one another. Module sharing was not made any easier by this. And related to that, the copy-paste problem with reusing functionality. So even with the module pattern, we didn't really get what we mean when we say modularity. We didn't get all of those benefits that we wanted. So that brings us to the next phase. Specification. So what's getting specified here is a format that modules should take so we can consistently know and reliably know how we're going to load them and send them out into the world. And as in the last era, we start with a manifesto. Around 2009 or 2010, people were feeling two strong emotions about JavaScript. On one hand, people were very excited about JavaScript's potential as a language, and folks who were especially working on the server side were excited to see that JavaScript could be used on the server side. So great excitement on one hand, great frustration on the other. Frustration about the limitations of the language and all the things we wanted to do with it. But remember, little baby JavaScript coming from Mr. Brendan Eich's womb wasn't really built for any of the things, any of these expectations that we're piling onto JavaScript. So Kevin Dangoor, another name that I may be butchering, my respects to him, wrote a blog post in January of 2009 that was called What Server-Side JavaScript Needs. And he outlined a proposal that included, among other things, a module system. So there are some other things that he proposed, and many of them we actually know and love today. So he talked about having a package system for deploying and distributing modules. He talked about having some kind of package repository for finding and installing these distributed modules. And none of this existed at the time. This was all kind of a pipe dream. Like, wouldn't it be nice? Wouldn't it be nice if we, as a JavaScript community, had these resources available to us? He talked about cross-interpreter standard libraries also being important. So APIs that could be used across different browsers, like Date and Math, already were at that time. So he said, you know, wouldn't it be great if we had an API for the file system that was consistent across browsers? Anyway. The bottom line is that Dangoor felt that what he was describing was not actually a technical problem. It was an organizational problem. It was about finding consensus among the JavaScript community, bringing people together so they could make a decision and step forward and start building something bigger, something better together. So like adopting a common currency or a common language. His blog post, which you're welcome to check out, ultimately led to the formation of a grassroots group of similarly fed up developers who called themselves, eventually, or Commonjs. And they decided that they would start setting some standards for JavaScript, including standardizing module loading. So, not too long after that, Node came out, just a few months later, so this was May 2009. Dangoor wrote his blog post in January. And they created a module implementation which has since taken the name Commonjs, but it's distinct from that original group. As we'll see, that original group didn't end up meeting all of their goals. They kind of created some things that they didn't mean to But anyway, Node had a number of competitors at the time that were also in the business of creating server-side environments for JavaScript, but Node won, and the CJS, the Commonjs specification name stuck with the Node implementation. So that's what we think of when we say Commonjs today. We're talking about Node's implementation of modules. And the Commonjs spec stipulates support for module loading via a require method and assigning exports to this property on the module object called module.exports. And this was really designed with server development in mind. That will become important in a few minutes. You might be working in Node already, but if you're not, and if you're not hanging out in CJS regularly, we'll have a quick look at the syntax. We've got an awesome.js file here, and we are exporting as its module interface this awesome person function that says so-and-so is awesome. I wish I had people affirming me like that all the time. And in some other file, we are using that wonderful require method to bring in that awesome person functionality. And that require method is going to have you load a module, and now you can have dependencies. The require function is actually really powerful. It is something that will block Node's thread of execution. Module loading in Node is synchronous. Not a big deal, actually, because on the server side, you're working typically with file systems, and your files are there already. It's not a huge tax or a huge cost to be dealing with synchronous module loading in Node. But I'll walk through a few fun pointers related to the require method. One thing that I learned actually this year while working on that React project was that Node actually caches its modules. And it looks in the cache first to see if the module has already been created as a module instance. And so the fun repercussions of that are that you could potentially modify that module after caching it. And then when you're working with that same module again, it might have some additional properties that you might have assigned to it. It may have, it can change or evolve and have all of those properties that you give it. And then this module._load function that's kind of under the hood of the require method then calls this module._compile function, and that's where the magic happens. This method creates a special require function. Actually, it's specific to every module instance that's being created, and it generates a wrapper function. So remember, just like with the module pattern, where we had to scope things, scope the contents that we wanted sort of protected in a module within a function so that we could have that little pile of data and functionality and properly scoped variables. Same trick here, a little more sophisticated, but we're still using function scopes. And then it actually runs that wrapper function on the spot. And I think I want to highlight here that all of this kind of happens at once. You start wherever your entry is into your, you start wherever, with whatever file you're entering into, you hit your require statement, Node goes off to another file, does its thing, doesn't move on until it comes back and finishes its trail of dependency unwinding. So anyway, so in case you're curious, here's what the wrapper function roughly looks like. I just grabbed this from the Node docs in GitHub. They've got a nice little README type page on modules. And yeah, kind of made this point already, but function scoping is a powerful tool in JavaScript. Nothing outlives the execution of that wrapper function except what's actually exported from that module. And that's, I think I say that, yeah. So that wrapper function will assign whatever is being exported to that file to the module.exports, and off you go, you have whatever you wanted that was exported from that file. File name and dir name are just convenience variables, so you don't have to type out the whole path and directory. It's nice that Node did that for us. So there are, of course, options for using the Commonjs module format on the browser. Many of us are, again, doing some kind of transpilation to whatever newfangled JavaScript code we're using so that we have continued compatibility. Anyway, so CJS wanders beyond the server every now and again if we wanted to. We can use those require methods if we want to. So remember our friends at Commonjs, like the group of fed-up developers, not the specification. So in a strange plot twist, even though they were really talking about JavaScript for the server side, they didn't succeed in offering any kind of usable spec for the server side, but they did create one for the client called Asynchronous Module Definition, or AMD. Quick look at the syntax there. This define method takes as its first parameter this array of dependencies, and then it has this function that it's going to fire off once those dependencies have been loaded. True to its method, it is asynchronous. It is better suited to the browser. And require.js is one of the more popular libraries folks are using with AMD. And then UMD, the Universal Module Definition, which I heard a developer, or I read that a developer was joking that when you try to please everybody, no one leaves happy. So this was an attempt to support both the CJS spec and the AMD spec. And with this hulk of boilerplate, as you might imagine, it never really caught on. No one wants to do that. No one wants to do that. So rest in peace, UMD. I'm sure there are people, or I'm sure there are some code bases that are using it. Anyway, so we may say that specifications really flourished in the early part of this decade, but while they were a wonderful thing, and while there was a lot of innovation and a lot of effort to come up with specifications that we all use, it is possible to have too much of a good thing. Czech Glowacki, man, all these names are hard. He was a member of Ember's core team, and he wrote in 2014 that unless all dependencies use the same module format, dependency tree of depth greater than 1 is so painful, nobody does it. Nobody agrees on a solution to this problem. We are all fucked. So anyway, specification hell. And finally, that brings us to the last part of our tour. Where are we now? Well, I really wish I could tie up this presentation in a nice bow, but the fact is that we're still kind of in the awkward teenager phase of JavaScript really finding its adulthood and finding its way of living up to the expectations we've put on it. We've seen a lot of far from ideal solutions, but we finally do have a built-in module system, and that's a huge leap forward in the development of a language that was never supposed to come this far. So think about where we started. ES modules actually are supported by all major browsers as of this year. I think it was last month, actually, that Firefox just released their ES modules compatible version. And there's a lot of talk about how ES modules are asynchronous. That's not exactly right. Really depends on the loader. We can talk a little bit about that, but I think that's probably beyond the scope of what we can talk about tonight. But other cool things include support for cyclic dependencies. So those are dependencies that either depend on each other directly or with a few degrees of separation in between. I'm not going to go too deep under the hood with ES modules today, but let's at least look at this beautiful and consistent and concise syntax that it offers us. We've got two export types on the left. We can have default exports. Some of this may be review for those of you who are doing this on a daily basis. We can have named exports. So here I've got a default export coming from a message.js file. I've got 3 little trivial arithmetic functions that are coming from a library.js file. And then their corresponding import methods. So we can import whatever we exported as a default export using the import statement like so with the word from. When we're dealing with a file that has multiple named exports, then we have the option of importing all of them. We can even give a name to the containing object. So importing all of these little functions as lib, or I guess I could have called it arithmetic or something from lib.js. We can selectively decide which parts of the interface that we want to bring in using, I guess this is kind of, it's not exactly, I guess it's kind of object destructuring. Yeah, I would call that object destructuring. Cool. And in the browser, we still have our trusty old script tag that has survived many years of JavaScript. But now we have a new special attribute called type called type, and we can assign it module to let the browser know this is not regular JavaScript that you're going to be parsing. You're going to be looking at a module file, and that has to be handled differently. So JavaScript can begin its process of module loading, building out a dependency tree, and all of that. We also have a fallback for older browsers. So when you have the no module attribute, this is going to be ignored by those modern browsers that are using modules natively. The no module attribute says, ignore me to those browsers, but if you are not in one of those browsers, if you're in an older browser, you've got your trusty bundled regular JavaScript file in all of its global variable glory. One of the conflicts, one of the current issues in JavaScript is that while most browsers are up to speed with ES modules, Node is not. And you might be asking yourself why Node and ES modules can't just get along. Well, the implementation actually is pending. I was able to play around with it a little bit and just make sure you have the most current version of Node and just use the, I think it's called experimental modules flag or something, experimental something flag. And you can absolutely play with them in Node. But really what's going on is that ES modules and Commonjs modules, these are really different specifications. So when I was talking about Node earlier, doing the synchronous loading and execution of those wrapper functions that it was creating with require, that's a really different approach to modules than ES modules. It's just, they don't play nicely together. They are two different concepts of modules. So one of the things that's caused a lot of contention is the .mjs, I think it's modular JavaScript file extension, which is basically to node what the type equals module attribute on the script tag was to the browser. So this .mjs file extension says to node, hey, you're about to parse an ES module file. Some people have called it the Michael Jackson script file extension. Anyway, as I said, I wish I could just wrap this up in a tidy bow, but there are still a lot of questions about what the future is going to look like. There's a lot of thought that ES modules and HTTP2 will be very complementary to each other with the possibility of server push and being able to sort of chunk out bits of code quickly on demand. And yeah, I think we have yet to see what's to come, and we're kind of in an exciting phase in the life, the not so long life of JavaScript. I think it must be in its, I'm terrible at arithmetic, its 23rd year. It's going into its 23rd year, just its young adulthood, and we all get to be a part of that. And maybe at the end of that, we will get to the promised land. Thank you.